All right, so here is your foldable on simplifying radicals. So I have just flipped up the first page here, and we're looking at numerical expressions, okay? This should be a review for you, but if it's not, that's okay. We'll just take a look at how to simplify these square roots. Okay, so what we're going to do first, well, first let's see, write out one of our our radical rules. Okay, so if we have a product under the radical, like a times b, we can write that. We can split that up into two different radicals as the square root of a times the square root of b. Okay, so if they're being multiplied together, not added or subtracted, but just multiplied, then we can split them up like that. If we have a quotient under the radical, we can also split that up as the square root of a over the square root of b, the square root of the numerator over the square root of the denominator. And these actually go both ways. Okay, so if I was trying to multiply two radicals together, we can combine them as the product underneath. Okay, so it goes both ways. So with that being said, let's look at the square root of 12. What we want to do is we want to find factors of the radicand. So the number under the radical is called the radicand. We want to find factors of the radicand that are perfect squares. Okay, and your perfect squares are numbers that when you take the square root of them, you get a whole number. So like 1, 4, 9, 16, 25, etc. You should know these all the way up to 100. Okay, well, I'll just write the rest of them. 25, 36, 49, 64, 81, and then 100. Okay, so those are kind of the numbers that we're going to be looking at right now. So if we look at 12, factors of 12 that are perfect squares. Well, we do have factors of 12. We could rewrite this as the square root of 4 times 5, right? 4 times 5, I'm sorry, not 5. 4 times 3 is 12. Okay, so we just wrote it as a product underneath here, and then we can split it up as the square root of 4 times the square root of 3. And then we simplify from here. The square root of 4 we can simplify to 2, and then that's still being multiplied by the square root of 3. So that is this radical simplified. Okay, let's look at another one. 27. So right away I know that 9 is a factor of 27. 9 times 3. Then we can split it up as the square root of 9 times the square root of 3. We can simplify the square root of 9 as 3, and then that's still being multiplied by root 3 because we cannot simplify this one at all. Okay, I'll do one more here, and then I'll leave. Guess I could do the last two to give you practice. I'll do 4 and you do 4. Okay, the square root of 50, so 25 is a perfect square, and it's a factor of 50, so we can write it like that. Separate it into the square root of 25 times the square root of 2, simplifying this down to 5 times root 2. Okay, and 32 is the last one. We can write this as the square root of 16 times 2. 16 times 2 is 32. Then we have the square root of 16 times the square root of 2. That simplifies to 4 times the square root of 2. All right, so there's your numeric square roots, how to simplify those. So let's take a look at if we have variables instead of numbers. Okay, so these will... let's see, we have some notes here on this. I don't know what color is going to show up. To simplify radicals with variables, divide any even exponent by 2. Okay? Break apart any odd exponent by separating one base from the rest. And even to odd exponents get absolute value bars when simplified. Okay, so let's look at this. So we have x squared. This is an even exponent, so we're just going to divide it by 2 when we get rid of the radical. So just a side note here, the square root and the square, like the exponent of 2 and the square root, these are opposite operations, okay? They undo each other. So that's why we look for even exponents. Okay, so we just divide the even exponent by 2. 2 divided by 2 is 1, so we can write x with the exponent of 1, but we don't need to write that. And then if we're going from an even exponent to an odd exponent, then it will need to have absolute value bars here, like that. Okay, so this is that one simplified. Let's look at the second one. For odd exponents, we separate one base from the rest, so we can rewrite this as x squared times x, right? Which we know x squared times x, we add the exponents, 2 plus 1 is equal to 3, so these are equal to each other. And then we separate these out, x squared, the square root of x squared times the square root of x. And then we simplify this first one down to x times the square root of x. Okay, so let's look at x to the 4th. This is an even one, so we're going to divide by 2. 4 divided by 2 is 2. So this is just equal to x squared. We look at x to the 5th. We can write this as, so we'll break apart one base and leave the rest, which will give us an even number. And then one single base on its own. We write this as square root of x to the 4th times the square root of x. This simplifies down to x squared, square root of x. Okay, so you continue on here. Well, it looks like we have a little bit of mixed. I'll do one mixed here. Okay, so when you have more than one variable under the radical, all you're going to do is you're just going to take each variable and look at it separately, and then at the end you'll put it back in. Okay, so x squared, the square root of x squared, we already said we know that that is x, so we can pull that out. And then y to the 8th, that's an even exponent, so we'll just divide that by 2 and we get y to the 4th. And we'll go ahead and put absolute value brackets around that x there. Okay, let's look at one more. So this x cubed will split apart into x squared times x, y times y to the 6th, that's fine, and then times z. So we know that we can take the square root of this and take the square root of this, so we're going to have x and z left over. The square root of x squared is going to be the absolute value of x. If we're going, so 6 divided by 2 is 3, so we're going from an even to an odd exponent, then we have the absolute value of y cubed, and then we're leaving an x and a z underneath. Okay, so go ahead and try the rest of those on your own, and then we'll look at the last page, which is the combination, which just means we're going to be doing, looking at simplifying the number and then each variable. Okay, so when we look at 40, the square root of 40, we're looking for factors that are perfect squares. So we have 4 times 10. A squared, we know we can take the square root of, so we can leave it as is because it's an even exponent, and b to the 8th is also an even exponent. Okay, so we know we can simplify this, simplify this, simplify this. This guy we cannot simplify, so that's going to stay under the radical. So when we take the square root of 4, we're going to get 2. If we take the square root of a squared, we're going to get the absolute value of a. If we take the square root of b to the 8th, we're going to get b to the 4th, and then the 10 will stay under the radical there. Okay, let's do one more. 18, we know we can write that as 9 times 2. X to the 3rd is an odd exponent, so we'll have to break it apart into the even and 1 left over, and then y to the 4th, we know we can simplify this, and this. What's going to be left under the radical will be the 2 and the x. So the square root of 9 we can take as 3, the square root of x squared we can take as the absolute value of x, and then y to the 4th we divide by 2 and we get y squared. And what's left under the radical is 2 and x. Okay, so try the rest of these on your own. These last two are being multiplied, so remember that if you're trying to multiply two radicals together, and this is only for multiplication, you can combine them as a product under the radical. So remember that rule for the last